Welcome to this quick session on gradient-based optimization. This is the second episode of Introduction to Optimization. You can see the first video I uploaded last week on my channel. Today we are going to break down this concept in the simplest way possible. Optimization. It's all about finding the best solution. We can categorize it as gradient-free optimization and gradient-based optimization. In this session, I'm not going to discuss about gradient-free optimization, but I'm focusing on gradient-based optimization. What is gradient-based optimization? For this, I'll give you the most common example. Imagine you are a hiker hiking in the mountains, and your goal is to find the lowest point in the valley. This is like solving a problem where you want to find the best solution. Gradient-based optimization helps you figure out the right direction to walk and how far to go to reach the bottom. When reaching the bottom, you have to consider some points. First one is initial guess. You start hiking at a random point on the mountain. This is your initial guess. You don't know if it's closer to the valley or not, but it's your starting point. Then you have to figure out where to go next. To figure out where to go next, you look at the slope around you. If the slope is steep, it tells you that you need to go down quickly in that direction. If it's gentle, you move more cautiously because the valley might be nearby. When going downhill, you have to consider about your step size. If your step size is too big, you might overshoot the valley and end up on the other side of the mountain. If you take tiny steps, it will take forever to reach the bottom. After taking a step, you stop, look around again, and figure out the new steepest direction to move. You keep repeating this process, taking steps downhill. Some of the most popular gradient-based algorithms are here. Gradient descent, stochastic gradient descent, mini-batch gradient descent, and momentum. But in this session, we are focusing on gradient descent. What is a gradient? Gradient is a measure of how steep a slope or a line is. Here, this graph shows you the function of y equals x plus 3 squared. So let's take that function. Our goal is to find out how y changes with respect to x, which means we are finding its derivatives. Next, we apply the power rule. We bring down this power value to the front and reduce the exponent by 1. And after that, we multiply it by the derivatives of the inner term x plus 3. So it's like this. 2 into x plus 3 to the power 1, the derivatives of this x plus 3 term is 1. And this is the simplified answer, 2 into x plus 3. Now let's apply the gradient descent algorithm step by step. I think you remember the initial guess in the hiking example. My initial guess is x0 equals 1. Then learning rate. It decides how big your steps are. You have to make sure your step size is neither too big nor too small. Mathematically, the step size is known as learning rate. Let's take it as 0.01. This is the gradient value as we calculated earlier. When x0 equals 1, the gradient value becomes 8. Let's take the first iteration. This is the equation to calculate the first iteration using gradient descent algorithm. x1 equals x0 minus learning rate into gradient value. x0 equals 1 learning rate is 0.01 and gradient value is 8. When we calculate this, it becomes 0.92. Great! We have taken our first step down the hill. On the second step, we repeat the process at x1 equals 0.92. We take this value from where we calculated the first iteration and learning rate is same. Gradient value also as we calculated earlier. When x1 equals 0.92, gradient value becomes 7.84. Let's look at the second iteration. When we calculate this x1 minus learning rate into gradient value, x2 value becomes 0.84. It's shown in the graph like this. Okay, we have to repeat this process until we reach the minimum value of the function. Here, the minimum value is -3. We have to find the global minimum. Our ultimate goal is to find the global minimum. That's the lowest point of the curve. But look at this diagram. It has several minimum points. Sometimes the mountain has small dips that aren't the lowest point, called local minima, as in this diagram. You might get stuck in one of these if you are not careful, but with the right technique, you can escape these and keep searching for the true bottom, our global minimum. If you found this video helpful, please like the video and share it with your friends. Subscribe my channel to watch more videos like this and hit the bell icon to get a notification when I upload my next video. Thank you all for watching this video.